This session is about a summary of curve sketching. We do have guidelines for the sketching a curve, and as we see, the first few points are telling us that we have to take care of the function and get all of the information, and then we have to take care of its first and the second derivative. And then collecting all of this information will allow us to get a graph of the function. But in this video, in this session, I will focus on one type of the question, which is something like that. We will have some information given, and we have to pick which graph match this information. Okay? So let's see which of the following graph satisfies the given condition. And we have a limit at infinity of the function f of x is positive infinity. This information is telling me that as x goes to negative infinity, function will go up. As we can see at graph A, at negative infinity is up. That means it is correct. B is correct. C is correct. However, D and E is not correct because function is going down. That means I can eliminate. Okay, the second information, the second limit at infinity of the function f of x is 1. This is the information about a horizontal line, which is a horizontal asymptote 1. And actually, we can see that the graph A, B, and C do have a horizontal asymptote and is respecting the asymptote. At positive infinity, we can see here, function is approaching the line 1. Okay, let's look at the next condition. Value at -1 and at 1 is 0. That means that's the x-intercept. And we do have -1 and 1, -1 and 1 for the graph B and C. We have -1 and 1, and also, let's say 3, additional x-intercept for the graph A. That means we have to eliminate this. Okay. And then let's see, graph B and C, they almost look the same. Function is decreasing and concave down on that interval. From 2 to infinity, function is decreasing and concave up. The only difference is between 0 and 2. Okay, between 0 and 2. And we can see function is increasing and the graph C is decreasing, okay, between 0 and 2. And we may notice that the information about the first derivative is less than 0. This means that function is decreasing. But my point is, we only have the information on the interval from negative infinity to 0 and from 2 to positive infinity, which these two functions has the same behavior. But we can't really distinguish the difference. Okay, let's look at the concavity, because I'm looking especially on the interval between 0 and 2, and I can see 0 and 1. That means, let's see, the second derivative is less than 0, which means function is concave down. Okay? Concave down from negative infinity to 0, which makes sense, and from 0 to 1. From 0 to 1, function is concave down. This one is concave up. That means this is not a good graph. Okay, that means based on this one information, I did distinguish the difference and I eliminate all of them, and this one is the corresponding graph to the given conditions. Okay, let's look at the other one. Similar thing. We do have a few conditions and a few graphs. Suppose that the function f of x satisfies the following properties. And we can see the first sentence the function is symmetric about the y-axis. This means that the function is even. If we remember the name, we don't have to remember at the moment, but that means we have to see the symmetry with respect to the y-axis. And I can nicely see at the graph A, graph B, graph C, however, D and E are not the graphs with the symmetry. Okay, we took this condition under the account. Let's look at the behavior, limits. Limit as x goes to 0 from the right-hand side is negative infinity. I mean, this is telling me that function has a vertical asymptote at 0. This is a vertical asymptote. And looks like each of them, A, B, and C, has a vertical asymptote. However, from the right-hand side at 0, function should go down to the negative infinity. A is doing this, and B is doing this. C is actually going up. I am eliminating. Okay, now limit at positive infinity, it's 1. This is the information about the horizontal line, horizontal asymptote. And we can nicely see both of them has it, okay? I can't eliminate. What is the difference? Yeah, let's keep looking at the condition. Second derivative, it's positive from 3 to infinity. This means that function is concave up from 3 to infinity. From 3 to infinity, it's concave up, makes sense. And actually, from 3 to infinity, this is concave down. Concave down, that means I will eliminate, and I end up with graph B, again B. And that means this condition gave me the difference. And I can stop, I don't have to analyze the rest of the conditions. We may double check, but we don't have to because we got our answer. But we can see how we can step by step eliminate the functions that they don't match the condition. Okay, question number 3. Now, instead of the list of the conditions, we do have a formula of the function and just the function. Okay, identify the graph of the curve x cubed over x squared minus 4. Okay, that means first of all, I see a rational function. Degree on the top, it's 1 greater than the degree of the denominator. And we know that this is the case for the slant asymptote. Okay, that means we have to have the slant asymptote. B, D, and E. A is gone and C is gone. Okay, we don't have to find exact formula. We know that it's positive, definitely, because x cubed divided by x squared, that will be the first step in the long division. It's positive, but we don't have to find the exact formula. We can see actually it's with the slant asymptote with the positive slope. Okay, second of all, I see that function, the domain of the function includes all of the numbers except 2 and negative 2. That means the lines 2 and negative 2 are not in the domain. And if I simplify, I mean rewrite, okay, I can see my factors, that's my function, negative 2 and positive 2. I can't simplify. Computing a limit at 2 or negative 2, I will definitely get infinities. I don't know what infinities, positive or negative, but definitely infinity. And this will tell me that at 2 and negative 2, we do have a vertical asymptote. Okay, that's me. Actually, all of the graphs, B, D, and E, have the vertical asymptote at negative 2 and 2. I can actually write vertical asymptote. Okay. Another way to possibly avoid the first derivative and testing increasing, decreasing, local maximum, minimum, I can try to look at the behavior of the function close to the asymptotes. That means, as I said, I will try to compute possibly a limit at 2 from the right-hand side. So we will see if the function goes up or down, positive infinity or negative infinity, respectively. Okay, that means let's see. If I substitute 2, I will have 2 cubed, it's 8. 2 plus 2 is 4, but 2 minus 2 is 0. Okay, and we know that this is not really 0, it's just a small number because it's not really 2. 2 from the right-hand side is 2.1, for example. 2.1 minus 2, it's a positive value, positive tiny number. That means a number over positive 0 will give me huge number, okay? A number over small number is big, but it's definitely positive because we do have. Okay, that means the function goes up at 2 from the right-hand side. And this function goes up at 2 from the right-hand side. And this one actually goes down, and this one goes down. I can nicely eliminate. And again, graph B is the correct graph. Okay? Of course, if I will not eliminate the function, I will keep working on my limits, the behavior on the left-hand side, and then I will take -2, and so on. Question number 4. Identify the graph of this function, x squared minus 2x plus 1 over x squared plus 3. Okay. What we have? The first thing that I see, this domain of this function actually are all of the numbers. Okay, all of the numbers are in the domain because denominator is never 0. If I will try to solve for the zeros from the denominator, I will end up with this quadratic expression being negative. Never. We have no solution. If it's no solutions, domain are all of the numbers. Actually, is that simple? Because we can definitely see -2, +2, +2, negative, positive as asymptotes. We do not have this asymptotes. Another maybe thing that just in case if I will not eliminate right away, I also see the degree of the function from the numerator and denominator is the same. It's x squared and x squared. That means limit at infinity of the function f of x, it's 1. And this is telling me that the horizontal asymptote is 1, just in case. And actually we do have 1. Okay, we have actually for every other functions 1. Okay, but I will stop working on this because I can definitely eliminate based on the domain only. Okay, number 5. Oh, number 5 maybe will be more exciting. We will have more challenge because what we see the first, we see a function, first derivative and second derivative. And I think probably we will need to use maybe derivatives to identify. Okay, that's me looking at the function again. I see that all of the numbers are in the domain because x squared plus 1 is never 0, which I can eliminate A, B, and E. Okay, that means C or D is the correct one. We have to check. 0 is definitely the x-intercept because for x equals to 0, if x equals to 0, it works for C and D. And what else? Limit at infinity of the function is 0 because limit at infinity of the function is 0, and this will be a horizontal asymptote. And we can see actually that graph D and C are respecting a line 0, which is x-axis, as an asymptote. Okay. Okay, that means I have to look at the first derivative. Looking at the first derivative, I see 1 and -1, the zeros of the top, and no zeros from the denominator. That means 1 and -1 are the critical points. And I can draw them on the number line. And I will try to use the first derivative test and see what is happening at -1 and at 1. Because we can see we do have exactly opposite situation. Local minimum, it's for the graph D, and for graph, and this is local maximum, and for the graph C is opposite. This is local maximum, and this is local minimum. That means let's try. I will put, let's look at this interval. I will put a test value. I can pick any number. Let's put -2. If I will put -2, my denominator is always positive. That means I am not worried for the denominator. But putting -2, -2 squared is positive 4. 1 minus 4 is negative number. Okay, that means this is negative. Putting 0, my other test value is 0 and then 2. 0 will give me actually positive because 1 minus 0. And 2, 1 minus 2 squared, it's again negative. It means how function behaves. Let's see. Function is decreasing and then increasing and again decreasing. We can nicely see local minimum value at -1 and local maximum at 1. That means graph D is the correct graph, not C. I need to see minimum and maximum. And I don't have to even touch the second derivative for concavity. Graph number 6, similar situation. Oh, actually, it is the same thing. It's almost the same. Okay, we can skip 6 because we can see right away all of the numbers are in the domain. That's not good because it's the vertical asymptotes. And 1 and -1 are the critical points, the zeros from the first derivative. It's just identical. And we will have the same situation. That means graph D is the correct one. You can double check, but this is this. And I have one more. Oh, okay, at least a little bit different. We have function, it's first and second derivative, and we have to identify. Okay, the formula for the function is x squared over x plus 8. 8, I mean -8, is not in the domain. That means -8, -8, -8. Okay, each of them has a vertical asymptote because we can't cancel out. I mean, this is definitely a vertical asymptote, x equals to 8. Okay, I can also see that the x-intercept is 0 because x squared equals to 0 if x is 0. That means this is 0, this is 0, this is 0. Oh, this doesn't have, and this doesn't have 0. That means we can eliminate. Okay, at least. I can also see that denominator has degree 1 less than the numerator. That means this is the case for the slant asymptote. And if I will divide x squared over x, that's how I will start, I will definitely have a positive slope. That means A and E has a positive slope for the slant asymptote, not C. C, we can see that the asymptote is going down, not good. Okay. And what we can do, we can try to use the first or second derivative. However, we can see the behavior at -8 from the left-hand side. It's different. At the graph A, function is going down. Okay, that means this is -infinity. On the graph E, function is going up. That means I will try to check how function behaves at -8 from the left-hand side. And x squared over x plus 8. Let's see. -8 squared is 64. And then -8 plus 8, of course, is 0. I can possibly write here. That means 64 over 0, of course, is a big number, but we have to work out the sign. This is not really -8. This is -8 from the left-hand side, which will be like -8.1. When I add 8, I have small number. can copy this actually one more time, but this will be negative number, okay? Because negative 8.1 plus 8 will give me negative number. Positive over negative is negative. That means we can see function must go down on the left-hand side at negative 8, not up. That's wrong. Okay, that means this is one type of the question from section 3.5. Just to recognize the graph based on the given formula or the given condition. Okay, thank you.